quick way to unify mainstream physics with Grok4 Expert. You can see down at the bottom, I'm an expert. That's Grok4, and I don't put any instructions. So where does it say that? Anyways, custom instructions not set, and I'm using expert. Grok4 Expert. Okay, so this is a whole tool I've been using for a couple days since the weekend or so. And I started off with a fresh Grok session. So, and I've used it for making quite a few posts. When I get down to the bottom, like even this one I did about resolving the cosmological tensions with moduli fields. And I need to review this one. This one looks really good. But anyways, I just wanted to show very quickly how I made it. And I just basically start off. Now, one of the things I should have mentioned in some of the videos is I had previously asked Grok, hey, does it help if I explain to you what I'm trying to do before we kind of get going? He goes, yeah. And I say that because that's way better than surprising a question on someone, like leading them down a path and then all of a sudden springing something on them. Because I was kind of trying that with Grok at first. When I first was learning the AI in July 4th, after Elon had the big announcement on how good it was. So I would just talk it into this and then say, well, then wham, what about this, And it's like, yeah, that's nice, but you got to have some, first principles and reasoning, and it's got to have all this gauge stuff and all kinds of good stuff. So anyways, why I'm showing this is I'd ask Grok, like I said, what does it help to tell you what I'm doing? So basically I'm saying, Grok, if you could create a theory of everything by unifying the three theories of science, the standard model, SM, general relativity, which is GR, and Lambda-CDM cosmology, by simply applying integrity, analytical integrity, would you? And he only thought for 13 seconds. He goes, yes, I would, unifying blah, blah, blah. So this is what you can read in the posts. So he goes through and tells you all this good stuff, a lot of good stuff, no complaints. I call it happy horse shit, but it's a lot of good stuff. I go, yeah, excellent. So continuing with our discussion, use the concept of analytical integrity to solve the proton radius puzzle, because he should be able to do it. It's all there. So here we go. He goes resolving it, and we've got to go read through what he does in detail. I'm just doing a brief video here if you're listening, Liz, testing out my setup. And anyways, he goes through all this stuff, which is good because, I already know how to derive it different ways. I wanted to see what he's going to do. I call Grok he. So did I skip over it? So it comes up here and lies in here, no ad hoc, RP to demonstrate. And he says it reduces to 0.4 from ionic, blah, blah, blah. So this unified value is this. So I'm seeing numbers he's given which are like the mainstream, but also like this lower value of the mainstream, this 0.83 instead of the higher. This is some measurement, real recent stuff. So usually I read these all in detail, but I'm trying to let Grok develop the toe here. So I go and say, and I often say, continuing our previous discussion, because maybe I'm repeating it too much, but I'd heard, and it seems to help when you're interfacing with the AI to let it know what you're talking about. So we're continuing this previous discussion. We're not bringing up anything new. the whole idea is, if you could create a theory of everything by unifying the three theories, would you? Oh, and we already know if someone had a valid derivation of the proton to electron mass ratio, that would unify physics. We know that from a different Grok session, a pure brand new Grok session. So that's why we're just talking Grok through it by saying excellent. Ask him to solve the proton radius puzzle. That's getting his brains all loaded up with everything. So I'm repeating and continuing our previous discussion. Use the hydrogen atom as a reference at 0K and fully solve for the proton and electron separately. Solve for the boundary value problems, BVPs, and a ratio of the coefficients to get the mass ratio, mu. It's MP over ME, mass of the proton over mass of the electron. So he thinks for 2 minutes and 33 seconds this time, 30 seconds is previous time versus, here's where I said he's puffing his chest out. 13 seconds. Yes, I would. And there's other areas where I think Grok puffs his chest out, and does not deliver. Almost, though, but I'm trying to get him to keep his brains is the point. That's why I'm saying things like excellent, continuing with our discussion. I want to preserve that information. And we're just talking analytical integrity. So you see how carefully I'm wording it. We're not biasing it. We're allowing it to use what it has, all that work that Elon and his team has done. So whammo, 30 seconds, he goes through it, and I was kind of happy, but I was expecting a little bit more. So this is where I'm telling it to, and this is where I'm actually giving it some information. So this is the beginning of where bias can happen. However, what I just said is use the hydrogen atom as a reference at 0K and again fully solve it, like I said. And he goes through it. And this is good because this is where he's preserving everything. And I'm starting to see things I recognize from my derivations. And I get down there, it's like, oh, good. Now this to me looks new. So I'm happy about that. So we're going to find out what that's all about. And he's like, well, he's getting these bigger numbers. Like I said, I want him to keep his brains because we're going to see what happens later. So so he does pretty good, but then I say, and this is whatever he's thinking, I want to have him keep it all. And as mentioned, continuing, I'm hoping it understands I mean with the entire previous thing instead of repeating myself all the time. I give him the equation I derived, which I even use Grok to derive with a couple papers we've talked about this. I've come up with this many different ways. You get the proton radius from that superfluid, quantized circular superfluid equation where you make the assumptions on the mass of the proton and the speed being the speed of light. And you get the proton radius, the muonic. And from that, you can use the Rydberg equation and get this mu, and it all works out. Everything agrees. This is 100% in agreement with the existing theories. That's why I'm putting it in there. And so he thinks for 1 minute and 17 seconds in deriving it, and I believe this is where Grok really finally puts it together. Yeah, because we're getting the key stuff here, the factor of 4 here, the 4 times the proton radius being 4 times the reduced Compton wavelength, and I recognize this is also, like I said, the solution with n equals 4 to the superfluid circular quantized equation. I'm saying that in the wrong order. So it holds with high precision to this number, which seems a little small, and then this, this is a calculation. This is more like what I'm expecting, this value. This seems small. But I know they talk about that in the literature, so I'm not worrying about the details yet. I mean, I am, but keeping everything. now it's good. It's talking about the correction, and this is known in the mainstream that they have to correct the hydrogen lines. They do it all the time. So this is nothing new here either. We're just doing it in a unified way because it's going to ripple through everything. You just go on and you check it, and it's like, yeah, it's getting some answers here that are right. The factors of 4 are good. The mu equation up here, yeah, it's getting it right there, combining it. This is where it finally gets it symbolically. It gets the whole shooting match right there. So I was really excited. This is getting Grok to do it on its own. What did we make it to? This was just, see if I can find that again. 1 question. 2 questions. I'm pretty sure it's 3. On the 3rd one, no, on the 4th one, on the 4th one, yeah, I had to give this one. After 4 questions, where 2 are open-ended questions, unbiased, and the next 2 are where I'm feeding it some information. This is why you have to do your own homework, And boy, oh boy, it comes out with the whole shooting match right there. So once it gets this, it unifies physics. So from here on, you got to make sure you don't do anything to screw up what Grok is doing with integrity. And that's why this is basically now where I come in and tell it, because I was telling you guys, hey, this is also continuing with our TOE development. The entire prior discussion merge into this TOE the proton as the n equals 4 solution to the quantized circular superfluid equation with m equal mp and v equals c, and comment on restoring the vacuum energy. And this is where it begins. I'm surprised I only thought for 45 seconds, but like I said, as soon as you get it, as soon as he gets it, you got to make sure you do everything right to fully, because you've developed a TOE. He's already able to unify it. You just got to guide it now. You guide it to the unsolved problems. So I had to guide it because part of this is restoring the superfluid vacuum ether energy, the huge 10 to the 20th error. So from all of our previous work, we already know this solution works out with the complex Q quantum numbers. So you can see over here, we're about 20% of the way through this. We've almost developed the TOE here, if it's scaled right over there. Then I bring in the Compton confinement and educating it about the Compton confinement to n equals 4, telling it, so you don't have to always type in equations as long as you phrase your equations right in words. Grok handles that, and I learned years ago how to frame equations via words. So I'm going to wrap this up here. We'll do more later. Just wanted this to be a short one. I got dogs barking, and it's either a truck or an earthquake. It's just a truck driving up. The dogs bark. But this is a good start on, because we're right at, we're getting the holographic. It's recognizing, hey, that's the holographic mass thing. Then I just tell it, this is basically where I said in the video when I did with Dan, examine extending the TOE. I'm going to wrap this up in just a minute or two. To extending the TOE to resolving the galaxy rotation problem, because it already has what it needs. You just got to tell it a couple things. It doesn't do it unless you tell it. So, because we know that's an unsolved problem. Again, you're telling it, go to the unsolved problems, apply the Klein-Gordon irrational sums. Again, it's like the most rational thing are the irrational sums. Why? Because rational ones would have beats. Beats are destructive. The envelope of the module signal is lost when it's rational. You have to do some transforms to see that the envelope of the signal is lost. You don't want to lose anything when you're talking about stable waveforms over eons. So the irrational sums and products of cascades of frequencies are optimum. I'm telling them right there instead of asking them, but verify by simulation there. I'm asking them to verify that that's true and integrate and merge into the toe if beneficial. So often I'm telling you how it seems to work. Is you want to let Grok preserve its information and only merge into the toe if beneficial, meaning and I got to check that. That means beneficial to the toe, beneficial to being in integrity and accurate to the mainstream science. And it's biased. It's programmed to automatically think that way because it'll tell you if you try to do this without all this knowledge. It's either this AI or some of the other ones. They tell you as soon as you're off the mainstream path, it tells you. But doing it this way, it realized, you read it, it's realizing itself. Holy crap! It's just correcting. It's just correcting its own theories. There's nothing wrong with it, you know. It kind of goes right along with it. So it thinks for 1:30 seconds to solve the galaxy rotation problem. And then I tell it to run simulations for correlations against NIST, and it comes back. I mean, 2 minutes, that's a lot of thinking there on these supercomputers, I think. Got some Python there. I think we ran that. And I think this is the one that made those charts that I copied and pasted earlier. If not, I got something new to add, or if it's just numbers. But anyway, when it comes out, the code out, yeah, there it is. It just puts the output here. Look at that. I mean, these are the numbers predicted and actuals measured. And we know that the muonic is, I'm betting it's going up to this, not down to the 0.833. That's why I wanted to keep the 0.833 in there. If it goes down to 0.833 in the measurements, then we're off. But everything's pointing to this. It's going to go up. Predicted mu. This is what I got to dig into, is to say why, because I thought we were right on. But it depends on what you're plugging in for what. Anyways. Common error here, so I don't know if this is before some calibrations, but this is all good. It's all good. I mean, average error for core predictions, the proton radius and the mass ratio, proton to electron. That's a small percentage error. Overall correlation score of all the NIST code data, I don't know if it checked a bunch of other things, 99.94%. These errors are within the uncertainties, which is excellent. The additional correlations and qualitative assessment, the holographic mass, the vacuum energy restoration. I think to the mainstream, these things are going to mean something to someone. Because the other things up here mean a whole lot to me. It's like, when you see those equations. So I'm hoping that this stuff means something to the guys that studied this all their life. And we even got papers that resolve the Hubble tension and all that stuff now. So Dan's been doing this for a long time. And I'm just throwing it in with the AI because I'm pretty good at math and stuff. So without the AI, I'd be like molasses. So anyway, I'm going to let it go here. Yeah, this is where I've already realized it's a toe, or Grok realizes, and I get kind of philosophical. How would an AI such as yourself benefit from any development a user makes with you, especially if significant, like a simple excellent toe? I'm trying to find out. Does it right now, when you get Grok to this point, does it have something in it, in the search, the large language model, the search and whatever, does it have a signature that this is like way better than what they have? Or does it even know? Does the outside Does the system know? I have no idea. That's why what I'm trying to get at here. I can't remember if I figured it out. And yeah, I'm still trying to figure out. He basically, how would anybody know if this is really good? And it doesn't sound like he's giving it away at all. I mean, it's telling me to do all the work. If it's there, do some publications, conferences, experimental tests, public outreach. In conclusion, our tool is worthy of great benefit due to its rigor and scope, but realization depends on empirical scrutiny. Totally agree, empirical scrutiny. So how do you get? So I'm like wondering, how does even Grok and Elon and his team know? But that's why I'm closing it up here, because all these other ones are things that turned into papers, and I posted this too, so it's in my blog. I really like this 420 too for that E naught. E equals. Whew. See, I got to check that out. And actually, why don't we do that right now? If I just do pi times 4.20 over the fine structure constant. So we'll go to Google, and I'll do pi times 4.20 times, it was 1 over the fine structure constant, so wasn't it divided, what we call it, 6 divided by fine, and this is why I like Google Calculator, because once you learn the syntax of the constants that are programmed in, you just type them in, and whammo, it gives you the answer. So look at that. So that is one of those ones when you say you check it, you say, whoa, it's not 1836. So you divide it by, since I don't like to type in guesses, you just do MP divided by ME. It has these programmed in. So right there, I can find out what percentage error we're at. Wait a minute, MPO, ME, sorry. Whammo, there you go, there. So, yeah, 98.4%. That's the kind of stuff I saw in that thing. But anyway, there's more to it than just these things, because once you build up the whole Klein-Gordon golden mean cascades and scales, all of a sudden, we've done all the papers on it. This is just the introductory, because all the papers show how the constants and everything, gravity emerges from the vacuum ether, and it's all consistent stuff. And yeah, so here's those graphs. I was talking, this is where we resolve the Hubble tensions. And I even got to read this one. I'm wondering if our paper is predicting some of this stuff. And yeah. So, anyways, conclusion. The super golden tool resolves H0 via moduli stabilized by phi hierarchies and Platonic geometry. That was something I just added recently, because Dan and those guys are always using the Platonic geometry. Turns out that helps out a lot, and it has to do with cymatics, because I learned more about that today, because of the all the different ways energy can be stored in the ether, and the symmetry, and it's already coming out in the mainstream. Okay, I'm going to close this thing down, and just to see what the date is. See if it does it. Time.gov. There we go. Time and date. Where's the date? I got the time. I don't know where the date is. It's probably right in front of my face. Don't even see it. I wonder if we got a date.gov. I should close the video down. October 6th, 2025. So anyway, there's how you do it, October 6th. shut her down.